Hello, everyone. I'm Agnieszka. If you want to talk with me later, you can call me Aga. You don't need to practice my name and surname. And today, I want to talk about automated testing in SDK. 3 years ago, when I joined eyeo as a person responsible for the quality of the engine that is behind the web extension, I thought that I will be bored at work because the team had fully automated pipeline, good coverage of the tests, and I thought that it will be only a matter of adding few more tests, and that will be all. After those 3 years, I can tell you that I was far away from the truth, and this session will be about lessons I've learned, ideas I had to drop, and challenges I had and my team had while automating the tests and maintaining the good and effective tests that are for the solution that is empowering web extension for the ad filtering. So this session will be divided into 3 chapters, which I feel are the base of the good automation pipeline. And it doesn't matter if you are working on the browser SDK, if you are working on the SDK that is empowering the extension. It can be also backend and frontend automation. So first one will be about what kind of tests should we perform, and here I will indeed focus mostly on the SDK. Then we will talk about protecting the environment, and as a third part will be the most crucial question I have: how fast is your feedback loop? And I would like to ask yourself, if you are developing a software, to ask also this question when you are working on the automation. So let's go. When we are thinking about the SDK, we are thinking about the special case of the software that is going to be integrated into the other software. So it's not working standalone usually, it has to be integrated. So that makes it a special case and might be tricky to say what kind of test we should perform. Also, because it's working in a browser API and in browser environment, it's getting even more tricky. So answering this question might be really tough. Partially, we have answer in the testing pyramid. By the book, testing pyramid shows you the levels of the tests, the quantity of the tests that you have, and also how expensive they are in terms of the maintenance and how fast they are in terms of the running them of the pipeline, and also level of the integration. In our team, we modified this testing pyramid. That's why I said this is only partially answering the question. We have different levels on the top because of the integration thing that I've mentioned previously. So now I want to go through each of the stages to show you why we did that and why it looks like this in our team. First one, the base one, are the unit and functional tests, which are common one for I guess, every software development product that we have. I want to mention here that on unit and functional level, if we are treating them in separation, we should consider when we are working with the web browser extension SDK, we should consider that we are mocking external dependencies on unit level on much more wider scope, meaning that we are also mocking the browser API. We are creating our own APIs to test if the whole small pieces of the software are working. On the functional level, though, we should already use the browser API and use the real test extension for testing, but mock all of the different levels of the communication, like getting the filter lists, telemetry, and all the things that is communicating with our SDK to perform proper functions. Then, next level on our test pyramid were fast tests. Sometimes they are called, sometimes mutation tests, that I will be speaking later on about, are called fast tests, but in our case, fast tests is an invention that we had in a team, and it's a special case for Manifest v3. In Manifest v3, we have service workers that are event-driven and can be suspended anytime browser decides that they are not in use. So we had to come out with an idea how to solve that problem, because if we will do it in functional tests, then we will have to set a lot of timeouts and sleeps waiting for the service worker to stop, and we won't know when it will happen. So we decided to do it programmatically, and we introduced these fast tests that are just suspending service workers programmatically and checking if the functionality works in that case. That's why it's higher level. It's still using the scope of the functional test, but it has this additional mechanism. Then we have integration tests. For most of the QAs, integration tests are like normal thing. So why I'm saying that we are doing it differently? It's because of the perspective. Usually, when we are talking about the integration, we are talking about testing the integration between backend and frontend. Here we don't have a backend and frontend. We are kind of backend, but we don't have the team that we can work on to test the integration. So it's really important that if we are releasing SDK or library or module to any other team or any other company, to test it from a bit different perspective, to test if integration is easy to perform for the integrators itself. So asking those four questions is really, really crucial. Is it easy to plug your library? Is it easy to call APIs? Is it possible to build your library outside of the directory of the library? Do you have functional tests for the prerequisites? If you have any scripts that are preparing the data for your SDK, you need to perform functional tests here as well. And if you are doing a breaking change update, you should check the data flow and the update of the process while doing this integration tests. Then we have this next level when we are talking about the normal by-the-book testing parameter of end-to-end tests, sometimes also called by the QA people integration tests. Sometimes they are mixed, sometimes they are different. It depends on the scope and on the decision of the team. In our team, we also tried to approach integration and end-to-end tests on our side, even though end, meaning the extension, was in the different company and in few different teams. So first approach, when we started to work with this additional pipeline, was to just let integrator tests after the release. And it was handled by the different team. It was tested after the release, and it wasn't efficient. We struggled with a lot of back and forth communication. We had a lot of bugs being reported afterwards. We had to release patches. So we decided to take control over this flow. And we just plugged our library into the extension and tested it automatically because we still wanted to maintain fully automatic pipelines. We took ABP and we just took the code that we want to release, we plugged it together, and we tried to test it. And it worked for a month until we released breaking change. When we released breaking change, tests started to fail. Then we fixed it. And again, there was a change on the AdBlock Plus side, on the pipelines, on the way how they build it. So we had a failing test, and we had to spend another few hours figuring out why they started to fail after some merge requests. And then we also realized that that was the only one integration, and we have multiple integrations. How we will solve the problem of the multiple integrations with all of the products? Will we be maintaining all of those pipelines? So we decided to just drop the idea of end-to-end tests totally. And we introduced two different security checks. We ask ourselves what is the purpose that we need to achieve, and what is the goal that we want to have, and what kind of quality we want to assure with this next level of the tests, because it's after the integration part. And how can we achieve it? And we introduced, again, new invention called compliance tests, which are visual comparison of the screenshots of the pages that are widely used in eyeo in different ad filtering solutions. So we already have kind of example of how ad filtering solutions should work with specific filters, and we can just easily test our test extension against that and check if it's working properly. Those are not integration tests because we are using our own test extension, and those are more like telling us that we are compliant with all of the products and we are providing end functionality that is working properly. It doesn't matter how integrators will work with that. Next step that we are currently looking into is contract tests idea. It's new idea if we compare it with integration tests or end-to-end tests. And basically, this is the this is the flow where tests are done against the contract. They are on the unit level or on functional level, depends how team want to set the scope. But the most important thing here is that there is a JSON file, usually sticked to the version of the SDK library backend, if you're working with backend and frontend. And you say there what kind of input values will produce expected output values. And this is the contract between the team working on the backend, called here as a provider. In our case, it's an NPM module or library. And front-end, meaning, in our case, extension. This is very beneficial for both teams because both extension team and team working on the solution can test against the same contract and make sure that they are compatible. And that's kind of pre-integration tests for the end user, meaning integrators, but for our team working on SDK, it's end test that will tell us that we are compliant with the expectations that they will have. Also, that is focusing on the messages that flow between both backend and frontend, while previous one were most like checking the visual outcome of the flow. With that in mind, we could say, okay, our tests are now good enough and we are like out of the work, but that's not all. During those 3 years, we've learned as a team that you should also treat your tests. Doesn't matter, unit, functional, integration, end-to-end tests, you should treat them as a separate product. And you also should check the quality of your product, meaning those tests. So there are 3 questions that also you should consider answering on your automated pipelines to make sure that your tests are good enough and will catch the bug. First one will be, will they catch the bug? That might sound obvious. That's the reason why we are writing the code and why we are writing the code for the tests. But in this case, it's not only about code coverage and catching the functional bug, but it's catching the mistakes done by different developers who doesn't understand why specific value is set in the code. So mutation tests are the tests that are checking if your code if your unit test or functional test will catch the bug if someone will just change some values that are really critical for your code. So they are just running random mutations in the code and then running unit tests and checking if they are working, if the unit tests are catching those kind of bugs. So it's kind of safety check for us. Second one is, do they rely on each other? It's very critical when we are working with the filter list and SDK that is working with the filter list, because we are reusing the same filter list, and sometimes it might happen that we are running the tests that are relying on each other, and when you start to run them on isolation, they will start producing different kind of results. And that's why it's so important to, not on every pipeline, but at least nightly, run that kind of test that is checking if tests in isolation are producing the same result as with all the set. And then there is the third thing. I think this is the most challenging in software development automation of the testing, because when we are testing, it works on our machine, then we push it to the pipeline, and sometimes it works, sometimes it fails, and we don't know if it fails because of the bug or because of the problems with the environment, or maybe because of some random bug because we forgot to set the timeout to be a higher one. So we, in our team, have nightly runs that are running 10 times in a row, every kind of tests, and checking if the test itself is producing the same result and is passing. If it's not passing and it's failing, then we are starting to reinvestigate what happened the day before to make sure that we are not creating that kind of fragility in our tests, and we are not introducing additional false negatives that might affect end user, or not end user, but us missing the bug if it will appear. The next thing is also related to the problems with the environment not working sometimes, and it's about protecting the environment. And here I have 3 rules, best practices that I'm trying to stick to, that make my life and my team much more easier, and I recommend also checking if you could also introduce it in your teams. So first one is, if you are testing on a browser, specify what version you support, but also, we were speaking previously about the sustainability. You won't be able to test on all of the browsers. You have to pick the critical ones. So you have to specify and communicate it to your integrators what browsers you tested on, because that makes whole communication with them much more easier and streamlined, because if they will find a bug in a browser that you didn't test, you don't need to debug, look for the logs. You already know that you didn't test it, and maybe it's worth considering to start testing it. Second thing is about sticking to the version. I know that for us, it's very tempting to test on the latest release version of the browser, because that makes us the best compatibility and making sure that we are on the top of the environment. But that leads to a problem that if you are running tests on the latest release, and you will merge the merge request, and browser introduce some performance delays or will introduce changes in the API, how would you know that your tests that started to fail are failing because of your code or because of the browser? If you are sticking to the specific version and, for example, nightly runs, check for the updates and run the updates 10 times in a row to make sure that they are not fragile, then you are safe. You can switch to the browser because you are sure that if you have failing tests, they are failing because of your code, not because of the tests that are happening on a different browser. And the third thing is the thing that I've mentioned. If you have testing environment, you should be able to repeat it on the developer's machine, on the QA machine if they are also running the tests. And third thing, you should have the same on the pipelines. Of course, sustainability here is also important, so reduce the scope of the workers that are running the tests, but make sure that you can repeat it, because there is very often a problem of developer running the test on machine and then running it on the pipeline and getting errors, and a lot of back and forth trying to figure out why it doesn't work on the pipeline. So try to make it repeatable through containers, through other solution, through the way to limit the resources and make sure that it's repeatable. And that leads us to the third part that I wanted to talk about, is about how fast is your feedback loop. And this is really important question to ask yourselves, because if your feedback loop is having 100 levels with different checks, checking all of the different angles, and your developers, or if you are a developer, you won't use it because it takes 2 hours to give you feedback, that makes no sense, because at the end you will be blindly developing something without testing it. You will at the end test it once and be surprised that there are so many issues and bugs and failing tests that it will be really hard to find where it is. So fail fast is a rule that we should all stick to, meaning moving all of the tests as fast and as early as we can in the development. Of course, there are some constraints like building time and all the stuff that we cannot change. But if we could move all of the tests to the moment where developer wants to check the code, that will reduce the time of the fixing the issues, that will reduce the time of the execution on the pipelines, and won't make us as developers to switch the context between the time when we are waiting for the feedback, we want to do something else, and we are losing the context where we were. So it's really important to allow to fail fast. And there is a rule that your automation should take less than 10 minutes to execute locally for the developer on the environment. And that's why it's so important to stick to this third rule of aiming to have fast feedback early, not only by moving automation to the early stages, to unit functional tests or any other like contract tests, which are faster than end-to-end tests, but also it's important to look for the opportunity to parallelize them, to improve the developer experience. Like maybe we could make one command that developer write npm run, tell me the truth, and waiting 10 minutes, and in 10 minutes, all the pipelines are run through Docker, through Kubernetes, and then we get answer. And this way, we can make much more better software and make this feedback much more faster. And also, here I wanted to mention, even though this presentation is about automated testing, but previously I was working also with the manual teams that were doing manual QA in the work, and I believe that some of us also have manual QAs in the teams. There is a rule of shifting left the manual testing, meaning don't move the test at the end of the development cycle, but try to introduce the manual test as early as you can in the development cycle. Ideally, provide the test cases to the developers before the development starts, so they have additional layer of the expectations, and they can also test themselves manually some of the stuff, making your testing much more faster, and also providing you much more reliable product that you can test, and you can focus more on exploration of the product instead of doing again the same work. With that all, I know that there was a lot of rules, a lot of questions, a lot of informations, so I prepared a few key takeaways that I wish you could take with you back home, back to the work, and maybe try to apply. So first one is let your code fail fast. If it has to fail, let it to fail very fast, very quickly, so we can fix it. Second, question quality of your tests. It's a product. It has to be good quality, and you have to check it. Third, dare to innovate. As I showed you with the testing pyramid, you don't need to follow by the book if it doesn't fit your goal and if it's not working. You have to then innovate and dare to innovate, to introduce new kind of tests that are not written anywhere. And last one, protect your environment to just have peace of mind in terms of testing when you push your code to the pipelines. With that all, thank you very much. I'm open for questions.
Thank you, Aga. I knew you had a lot of experience, but you're really knee-deep in tests and automations there. Questions from the audience for Aga? Oops, there you go. Where's the... Here it comes.
Sorry, you were first, right?
Thank you. Thank you for the talk, very inspiring. You mentioned that you are doing the test run like 10 times, and I was wondering how long it takes to do this all the run, and how do you apply this the fail fast principle there?
So this 10 times in a row are run on the nightly pipelines. So we are not running them. The same is with the isolation tests, because they take a lot of time to conduct. The 10 times takes 1.5 hours, while normal pipeline, full pipeline, takes 18 minutes. But the functional test, the most critical for us, takes 5 minutes. So the pipeline is huge. That's why we are running it on a scheduled job, and it's not affecting developers at all. That's why when we see that the pipeline is failing on the morning, we investigate what introduced it based on the merge request that landed the day before. So when we introduced it, we had to stabilize those 10 times in a row. Now we have base, and now we are running it. And when it's failing, that means that someone broke something day before, or maybe 2 days before, and we have to fix it. And also, as part of this pipeline, we are running those tests on a new version of the browser. And if it's not failing in 10 times within a few days, then we can upgrade safely to the new version of the browser. So it's not affecting the fail fast rule, because it's like outside of that. But sometimes developers, when they are developing new features or new tests, and they are not sure, they can also locally run this test, knowing that it takes 10 times. But that also is including new kind of scripts that we added that allows them to grab the test that they want to run 10 times, like new ones, to make sure that they are not fragile, which takes then, depending on the test, like 20 minutes to half of an hour.
And one more quick one. What are you using? Like, are you using virtual machines to run those, or what are you using for monitoring the, or maybe what tools can you recommend for monitoring the test results? Thank you.
So for the test results, we just check the pipelines. We don't monitor it through anything. Now, we have plans to have some nice-looking test reports, but we didn't get yet there, because we are focusing more on building the whole pipeline first and then deciding how to build it. And currently, we are running all of the jobs on GitLab shared runners. We had also, but it's Docker in Docker. So we also can create the same environment locally on our machines. And we are also investigating option to have our own custom runners that will be the same machines that we are running it locally. But now it's like next step that we are checking if we could do it. But on the Docker, we try to also limit the resources to make sure that we are running on the same resources locally and on the pipelines.
Thank you.
Thank you. You can pass the cube to
Sure.
over there.
Thank you for the talk. This is really, really exciting to see and really interesting. You mentioned that you don't always want to change the latest version of the browser because then you don't know if your code broke or if the browser caused the breakage. Not that browsers would ever introduce any bugs or anything like that, but...
I'm not saying that.
Isn't that also something that you would want to find if your extension doesn't work in the latest version of the browser, then either that could be something that you have to adapt to new behavior in the browser, or, like I say, not that browser vendors ever have bugs, but that you might want to let the browser vendor know, hey, this isn't working, maybe you changed something that needs to be fixed. How do you kind of balance that between having the consistency of your tests and making sure that you give browsers as much time to adapt as necessary, you adapt to the newest version as quickly as possible?
Yeah, so basically we are using not the latest released version, but the previous one usually, and we run nightly tests on both versions of the browsers if they are available, on the beta and on the latest release. So we already know in advance what's happening in beta, and sometimes it's failing because it's beta, so it's allowed to fail. We just watch what's happening there. And it's not like browser are introducing the bugs. It's more like deprecation of the APIs that we are using and we didn't spot on the release notes, or the performance changes. That's the biggest problem. If we limit the resources on Docker because we don't want to make it huge, we want to make our SDK working in specific environment, small environment. So when we are testing with the browser and there are performance changes with specific versions, then we get timeouts on our tests because some API didn't respond properly when we were asking for something. And that's the main reason why we are sticking to the previous version. It happened a few times already on the pipelines that we spot some bugs or something that wasn't working, and we were reporting to the browsers directly. And then we were just hanging on the previous safe version of the browser before waiting for new version to be released with fix. And then we were just skipping to the new version or trying to bypass it if we could, depending on the API possibilities and the situation that we had.
If you can test on even newer versions than beta, so our nightly or canary builds, that gives us more time to fix bugs so that it doesn't hit stable.
Okay.
So I take full responsibility for any bug that's ever been introduced in Chrome, so it's all my fault, you can blame me, but as much time as possible for us to fix them is really valuable for hearing how changes in the browser can affect extensions.
Okay, we'll try to test with canary. That's a good hint. Thank you.
Perfect. I think I would encourage the other questions to be asked in the coffee break, because we already will shorten it by a little bit. But yeah, Aga's around. Grab a cup of coffee downstairs, and I shall see you back in 17 minutes. 11:30. We continue here, and yeah, have a nice little coffee break. See you later.